The problem I examine is how to minimize the distance between patients and the nearest office location when deciding where to open a new facility. I use linear programming modeling and what-if analysis to find an optimal solution to this problem. To keep my scope manageable, I chose to create a scenario where TriHealth has recently hired new dermatology staff and is trying to decide where to put the new location. I use the database fed by TriHealth's electronic medical record system, EPIC, as the main source of data for my analysis. The query I wrote returns the patient medical record number, department, and address of the patient who completed office visit at one of our 7 existing group health dermatology locations between May 1st, 2017 and May 31st, 2017. From there, I was able to find the latitudes and longitudes based on the patient addresses. I also gathered the addresses for all group health locations, including the 3 that currently do not have a dermatology department. The design of my model allows Excel to find the difference between the coordinates to find a distance between patient addresses and office locations as the crow flies. My decision to only include the addresses of TriHealth dermatology patients does leave out the concept of bringing in new business through patients who previously didn't use TriHealth facilities. However, using the address of current TriHealth dermatology patients was a simple way for me to focus the population. For example, I did not want to create a model that used every address in the city of Cincinnati. The objective function of my model is to minimize the total distance between patient's home address and the closest dermatology facility. The addresses of both the office locations and the patient addresses have been converted to latitude and longitude in order to calculate the distance between the points. The closest facility is calculated by finding the distance between 8 different locations and each patient home address, then choosing the minimum distance for each point. 7 of the 8 locations are fixed, since there is currently a dermatology office in that building. The latitude and longitude of the 8th location are the decision variables for this model, since this is where we're able to change to optimize the model. The first model I created was unconstrained and allowed the decision variable to be any latitude and longitude in the world, as long as it minimized the total distance between patient homes and their closest dermatology location. This gave me a location out in Batavia, Ohio, circled in blue. I believe this location was given due to the vast distances traveled by the relatively small amount of patients that live out east of I-275. Therefore, putting a location out there did a great deal to minimize the total distance traveled, although the population was quite small out there, if you can remember the first set of red dots. I was curious to see the effect of outliers on this model, as some of the patients' address listed were extremely far from Cincinnati and may be unnecessarily skewing the results of the optimal output. For example, some patients' home addresses were listed in Cleveland. I found the outliers in my model by creating a normal distribution around the mean and removed any patient where the distance between their home address and downtown Cincinnati was more than 3 standard deviations from the mean of 15.76 miles from Cincinnati. I removed 45 patients from the dataset and reran the model. The output of this model can be seen in the green circle on the map. Out of curiosity, I also ran a model after removing patients over 2 standard deviations from the mean. The output of this model can be seen on an orange circle on this map. Since there is no drastic difference between the outputs, I chose to leave all the data in my model for further analysis. The unconstrained model finds the most optimal location regardless of what currently exists at the current longitude and latitude of the output value. However, a more realistic model would constrain the model to places where it is physically possible to build a building. In the context of this scenario, I want to constrain the model to use one of 3 existing buildings already occupied by group health offices. To do this, I first tried to create an evolutionary Excel solver model with if statement cells set to 0 or 1 to flag whether or not the decision variables were equal to one of the 3 possible locations. This gave me a feasibility error. I decided the simplest solution to the problem would be to create a what-if model using Scenario Manager in Excel. The output shows that opening a location at Group Health Finneytown, or the yellow dot on this map, minimizes the total distance driven by TriHealth dermatology patients. Based on my findings, if we were to open a new dermatology office in one of our existing Group Health locations, Group Health Finneytown would be the most ideal spot based purely on minimizing distance. While the concept behind my analysis is to find the most optimal location based on minimizing distances to current patient homes, it's important to note that the output of the analysis is only one piece of information that contributes to decision-making process for larger questions like where should we put a new facility, and the question preceding that is should we even open a new facility? I also want to point out the data can be found in Appendix A. In Appendix A, I did further analysis to see if patients in my data set are currently going to location nearest their home. It turns out that only 30.16% of patients are driving to the closest dermatology center for their appointments. This may be caused by a number of things, but I find it very odd that proximity to office isn't a more important driver of patient traffic. If I were to continue this research, I would like to dig into what's causing this to happen and see if there's a way to keep our patients from driving across the city to see their preferred physician. Thank you.